Century Electrotherapy Museum. This is an amazing institution. He's down in Pompano Beach, Florida, and he's got 8 of the earliest surviving Tesla coils, and he's got a tremendous array of devices, which I'm sure he's going to introduce you to. He was interested in this because as a teenager, he bought a device, a diathermy machine, and he was testing it out one day. The TV set started flashing, and he goes, oops, I better not have that TV plugged in. So he went around to unplug it, and it was already unplugged. He thought, okay, anything that makes a TV set flash when it's turned off is something I want to study. So he started studying these electrotherapy devices, and he has become rapidly and effectively one of the world's top experts in this field. And he also has a website, which is electrotherapymuseum.com, so you can stay in communication with him that way. And so let's welcome Jeff Beharry.
Thanks, Mike.
Do you have it now?
Oh, not yet. Let me take a look at that. A few technical difficulties. In the last decade and a half, I was just explaining to my good friend Frank here that having researched Tesla, I never run into as many problems as I did 10 minutes ago trying to get into these pants, which I didn't even bother to try on before the event. And it's a bit like trying to fit a pole transformer into one of these portable devices here. It just doesn't work. Here's a poem by one of favorite poets, Jovan Zmaj. Mislio bi čovek, kad pogleda mrak, da je strašno moćan, da je silno jak. To bi bilo naopako, al na sreću nije tako. Svećicu zažeži, a mak taki beži. It's basically a poem about darkness, and it shows the Slavic sense of humor in describing how beautiful darkness is and how intriguing it can be, where most other cultures would just say it's scary. The Slavs were actually intrigued by darkness. And the last few lines describe where just a tiny spark will make all of darkness disappear. And who better to make such a spark than Nikola Tesla? Just a quick description of the museum.
Is your mic on?
It should be on.
There we go. Okay. You won't need the other mic now.
Okay. The museum is, right now it's virtual. I get a few visitors each year, mainly from Europe, but anyone's welcome to come. It's just my house. And the online museum has over 30,000 files, all original to what's in the house. There's over 5,000 pages of ebooks, and most of these are turn-of-the-century books about Tesla technologies, but written during his lifetime. And they range from early X-ray uses of Tesla coils to pure quackery by the 30s of the violet ray devices and some of the sillier aspects. But in them, so much valuable information that you just can't find today. There's also original Tesla documents. There's some of the early, I have a first edition of Tesla's lectures and some original magazines published during his lifetime. The museum itself has right now around 100 coils. Most of them are in storage. 8 of the earliest surviving Tesla coils, these are, we'll tell a story later, they're actually recovered in a laboratory in Boston. It was underground. and they're still functioning embedded in beeswax and rosin sitting on a shelf. They're pancake coils. Over 500 glass plate negatives. Some of the examples of the exposures of them can be seen here of electric discharges. These were all made in the 1890s. And several tons of raw materials. Any apparatus I know doesn't exist, I at least try to build a reproduction of. And it's fairly useless to build a reproduction unless you build it as exact as possible. So I have stacks of mica and wood and beeswax and rosin and asbestos and things that you normally don't get these days. Tesla did some of his early work on Housden Street Lab. Here's some nice photos. You see the conical coil to the right, and up to the left is Mark Twain, his good friend. Most of this work was gone due to fire, was damaged, and unfortunately photos are all we have left of most of it. Some of the most interesting items he worked on in New York were his Tesla oscillators. And while most people are familiar with the Colorado Springs pictures, such as those shown here, the early Tesla oscillators, I think, are the most important for us to study because they show the true efficiencies of Tesla coils. And by the 30s and 40s, people started to experiment with them. They said they're inefficient devices, but none of the people that actually worked with them built Tesla coils as he did in the 1890s. And here are some good examples. You see, they don't look like most Tesla coils we know of today. Here's a reproduction I built of one. It doesn't have a transformer. Instead, it has just a single coil of wire, a self-induction coil with an interrupter. And if you know the old Model T coils, it's similar to that. And there's a condenser in the base, and the coil in the back is drastically different. It's a pancake coil. And this little unit consumes only about 20 watts and produces a good 4-inch spark from the terminals. And it was classic of what Tesla was using to fire up X-ray tubes and Crookes tubes in his lab in the 1890s. Up to the very top of the screen there's an X-ray tube being powered by this. And I swore I'd never get rid of this unit because it was the only one I knew of like it. But my dear friend Frank pointed out that I had the X-ray tube in the picture wired in the wrong direction. And I gave the coil to Frank after that because he's the only person on the planet I know that would have pointed that out and realized from the photo. Here's a continuation of some of those style coils. You see to the upper left is a basic style Tesla coil. You can see the primary and secondary. The primaries were actually wound with ribbon in these coils. There's a couple higher powered units down to the right. I have yet to build some of the Mercury interrupters and some of the fancy circuit controllers Tesla did, but I'm looking forward to doing that in the next year. How I build these coils, and most people say, well, how do you build that? There's no plans to any of that. We've never seen coils like this before. It's right in most of his lectures and patents. If you look at his patent for electrical transformer, a lot of people would think that's a low-frequency transformer, when in fact it's a high-frequency Tesla coil. It's two spirally wound coils wound in opposite directions. The primary is actually copper ribbon that goes over them. This was the basic laboratory Tesla coil. And by the end of the 1890s, Tesla perfected this to where the efficiencies were 85% or higher on all of his systems. To the right, you see his patents. Outside of the Tesla coil patent, he has many patents for electric circuit controllers. These are basically spark gaps or interrupters that use to power his coils, but they're also, the photos in the patents also outline the same complete systems that he designed. So you can see to the right there's a pancake coil next to a motor-driven interrupter and a few photos below. But all of these are directly from his patents. And it's kind of a mystery as to why no one's reproduced them in over 100 years right now, when the information's been right in front of us the whole time. To the left, you'll see the book I mentioned. It's the first edition of his 1893 lectures, Experiments with Alternate Currents of High Potential and Frequency. First edition's running around $1,500 right now, and it's only about 1/4 of an inch thick. Luckily, Barnes & Noble and some other places are selling beautiful reprints of the same thing. I don't regret buying this copy because it was an original obituary of Tesla used as a bookmark from '43. But you'll see some of his common photos from his lectures. He'd concentrated so much on electrical discharges, and a lot of people wonder why focus so much and so many pages just describing spark discharges? Well, the phenomenon associated later with electrotherapy, with producing X-rays, was all vital due to these discharges. The same coil could produce a variety of discharges, but one type of discharge is completely useless for X-rays, where it may be good therapeutically, and applications range scientifically the same way. Not all Tesla coils can be used to produce X-rays or for electrotherapy or for any of these concepts. It has to be specific types of discharges to do different things. On the top is a pseudostatic discharge. It's very similar to what you see in a Holtz machine or a Wimshurst machine, and it's produced with a Tesla coil. And anyone who would say it's completely painless would be in for a surprise if they took a discharge from one of these. It'll send you across the room despite the fact that it's high frequency. Under that is induced sparks. It's typical of what you'd see with an induction coil. And Tesla introduced his lectures with these two sparks because at the time it's what people were familiar with. Most people that experimented with high voltage at that time knew of only static machines or induction coils. He went into detail on spark discharges and brush streamers. These actually, he went into more detail on the lighting effects of electricity itself. You can see not only the sparks, but the effluves or the ionization around the discharges. St. Elmo's fire, it's one of the least photographed phenomenon, is a beautiful example of the effluves produced by a Tesla coil. The coils don't actually spark, but rather, well, they spark to some extent, but they ionize the air more so. Where in a beautiful coil operating, you may be able to approach it with your hand within a foot, and all of the air will ionize between your hand and the coil, but at the same time, it won't actually spark to your hand until a few inches away. And the lighting effects are incredible produced with these devices. He also described streamers or phantom discharges. And these are discharges that just, they emanate in like snakes, slowly moving away from the coil. And it's just one of those strange experiences of seeing these discharges. They're not a spark and they're not ionization, they're something in between. And physiologically, they have a very strange effect on the human body. If you reach your hand in them, it feels like you're being hit by a miniature hailstorm, which is how Tesla described it. And it's actually about the most accurate description I can think of also. Goes into spark discharges. The devices, at the top you see a basic spark discharge. At the bottom you see one interposed with the effluves. The same type of coil, depending how you operated it, using turn-of-the-century methods, gave a wide variety of discharge types. And now a lot of people switch to modern electronics, and you kind of lose some of these effects that you get with some of the earlier methods of production. Going into low power discharges, these are typical of what most people who experiment with Tesla coils would see. Once you switch over to some of the more efficient coil designs, like pancake coils, you begin to see the moderate power discharges, where the quantity of sparks and the quality of sparks is tremendously more. And next is the early X-ray coils had flaming discharges. This is something most Tesla enthusiasts haven't seen before. They're produced by the early X-ray pancake coils. systems. And this is an example here from a Fisher unit. It's about 10 inches between the terminals, and it bows up into a beautiful flame. What starts as purple sparks gets interposed with orange discharges, almost like a low-frequency discharge from like a Jacob's ladder. There's one step even more efficient than that, is a flaming white arc. And this phenomenon is literally like a welding transformer. And what can be drawn off several inches long from a Tesla coil actually can melt metal at the same time. And what's curious about it, in the electrodes you see here are 1/8-inch tungsten rods, and they actually incandesce while the coil's operating and start to disintegrate, which indicates a temperature over 6,000 degrees. But at the same time, you can hold a piece of metal and take this discharge to your body. It feels as if you're being microwaved as you are, but at the same time, it doesn't kill you. There's a slight video of this phenomenon repeating itself. It doesn't look like anything most people associate Tesla coils with. It looks like a low-frequency discharge from a transformer, but it's very high frequency. It was used to generate massive amounts of X-rays at the turn of the century. If you weren't careful, you could mess up one of your tubes very quickly. To the right, you see one of the flaming coils in operation. It'll start off as a spark and instantly turn into a white arc. And it's blinding enough that when I finished that, I burned my retinas for about a week and had trouble seeing, and discovered the hard way that this type of discharge isn't something you play with your naked eyes. What's curious is plasma effects of this type of arc without using inert gases. You can actually melt metal to a small extent, and this photo to the right, I put ball lightning, but it's curious because there's two entities in one of the photos that were just floating for a split second above the arc. Tesla went into elaborate details with the effects on insulators. And one of the photos you'll see in his lectures is of a thick piece of plate glass with a Tesla coil output on either side. And it's just incredible what you see if you operate a coil in that way. Rather than puncture the glass or not arc at all, it simply spreads out over the whole surface of the glass. And it's just spectacular to see. And it doesn't do the glass much good, though. It eventually gives away. He experimented a lot with lighting effects, not using vacuums, just normal air and ionization of air to light a room. Here are some coils you see just with wires just stretched across the coil and the air ionizing in between. It's extremely difficult to photograph this. What you see here is probably a quarter of what you can see with your eyes. The problem is with the cameras, it doesn't give off enough light for your camera to recognize. And because the light's moving, if you slow down the shutter to capture more light, it ends up so blurry that you can't really see it anyway. However, on film, you can capture it quite easily. And this is one of my favorite photos because you can see the ionization of the air. This coil is actually lighting over a square meter of light using about 50 watts of electricity. He had also had names on plaques of different people. Zmai, the poet in the beginning, was one of the ones he always used. This is some wires attached to a Tesla coil and the lighting effects just of the wire alone. Tesla did a lot of research with vacuum discharges, and people like Geisler and Crookes paved the way, and Tesla went far with it. You can see some Geisler tubes here, which are just normal air at different vacuums, and the effects of the sparks. Some of the tubing up here is some uranium glass that phosphoresces, that beautiful color. He also experimented with Crookes tubes, and this gets into borderline making X-rays. And the tube at the top is interesting. It's a paddle wheel tube. And as you electrify the tube, there's a mica fan inside that travels from one side of the tube to the next. And normally they painted them with phosphorescent paint so that as the fan is spinning, you actually see many different colors. It's an incredibly beautiful tube. There's the cathode ray tubes. To the right's a beautiful butterfly tube where it's a butterfly painted with the same phosphorescent minerals. And down below is a special type of rectifier tube for high-frequency alternating currents. This fancy photo here is actually of that fan spinning while that tube's in operation up above. It's a spectacular effect. He also experimented with phosphorescent bulbs. This is just a modern light bulb filled with argon. You can see the effects inside. Also with any bulb with a high vacuum, and phosphor on the outside will light up the same way. He also worked with single wire lamps. And if the tube has a high enough vacuum, it actually produces a large amount of X-rays as it's lighting up, but you can actually light up a single wire bulb using a Tesla coil. He did a lot of work with X-rays, and I've actually seen photos of more than 200 X-ray tubes that he had designed and made. Where they went, nobody knows, but it was around the 1890s. These were excited with Tesla coils. The one on the top is a helium-filled tube, similar to what Rife used in the 20s. Another curious experiment Tesla did was he noticed that when you operate X-ray tubes with only one wire or one pole, that you can actually increase the vacuum in the tube. And if you increase the voltage so much, the tube would get so hot that the glass would begin to soften. And at this point, tiny holes would form in the glass, and you would see discharges seem to escape. And reading the passages, it sounds like complete nonsense, but I've tried it here. And what you see is an actual arc striking from within the tube to a piece of metal outside the tube. And you'd instantly expect that since there's a high vacuum in the tube would completely implode at that point. But on the contrary, the vacuum actually got higher. It started to produce more intense X-rays, and eventually it did shatter. But the fact that it operated at all with a visible hole in it is something interesting and very, very strange. Canal rays are tubes on the right. They're actually positive ions. This was the first commercial Tesla coil to enter the market in 1896. Tesla didn't build it, but a company in Boston, LE Knott Apparatus, made it for the production of X-rays. There's a rotary spark gap to the right, which is recognizable. The coil is an oil-filled inside of this box, and there's a transformer and condenser on this side. It was not the most convenient apparatus to have, but it produced incredible X-rays, and very powerful X-rays. Compared to most induction coils, the discharge was phenomenal. Here you can see some of the internal components of that. It's wound on something similar to a bird cage. There's a primary coil. The secondary, which you can't see, is on the inside. And there's a discharge spark gap. Now there's a forgotten inventor who's really important to me. I started researching this man about a decade ago. His name's Thomas Burton Kinray. He's the man that designed a type of Tesla coil that was very convenient, very portable. It was only about 2 inches tall, you can see from his patent here, by 24 inches, and it contained 2 8-inch pancake coils inside. And this system produced an enormous discharge, over 12 inches long. It produced one of the flaming discharges from the earlier photos.
What's the patent number on that?
I can't see it offhand here.
615653.
Thank you.
Again, 615?
615653, I believe.
615653.
And all of his patents are on my website.
What's your website again?
Electrotherapymuseum.com. I'll tell you just a quick story. I got interested in Kinrade about 10 years ago. I had bought a book from Jim Hardesty. Jim and Judy live in New York. They have PV Scientific. Jim builds reproductions of static machines and induction coils and X-ray tubes, and one of the nicest people I ever met. And I received this book. He had a reprint from Strong called High Frequency Currents. And I opened the book to a page on Kinrade. And it basically just described this early Tesla coil, and I had never seen anything like it before. And incidentally, it's this coil here, and this is Kinrade. I became fascinated by it, and the description that Strong gave, just some small bit of magic about it. You could tell that Strong was an admirer of Kinrade. And oh, thank you. I started to reproduce some of Kinrade's coils in his work, and not really having much information to work on. I only actually found the patent to his coil after I started the research. And I told my wife we have to go up to Boston and try to find something original of his, not knowing if there was anything to be found. I had found a book on X-rays by Monell that said that Kinrade was one of the first people to photograph spark discharges. And again, with a book by Monell, the chapters he wrote on Kinrade, actually amounted to a few paragraphs, seemed so sincere that this guy had to have been something special. And anyway, my wife and I, we went to Boston, and I backtrack a bit. About a week before I left, I had found a patent application for sale of Kinrades, and I bought it. It was in England. And the address on the patent application was in Jamaica Plain, which is outside of Boston. I knew Kinrade was from Boston, but not exactly where. It had his actual street address on it. So I call up the house saying, "Oh, I'm Jeff Bihari, I'm a collector, and is your house 100 years old?" And they said, "Yeah, it sure is." And I told them I was interested in a man, Kinrade, and the man who lived there was actually a realtor. He had said, "Oh, yeah, I know Kinrade built the house. He's a legend in town, but no one knows what he did." And I'd asked if I could visit the house, and he had said, "Sure, why not?" And I go there, and I call him up, and the man was so kind because he had to leave out of town, and he actually had one of his friends let me in the house. It turned out to be a mahogany mansion. It's a 25-room house that's solid oak and mahogany, and it's situated on a hill. And I immediately went to the basement to rummage around to see what was there. And when I got there, there was a series of hidden rooms under the basement. And there I stumbled across what I'm about to show you here. It was the experience of a lifetime. I never expected to find anything on the man, much less be in his house and rummaging through the remains of his belongings.
Whose house was that?
Thomas Burton Kinrade. This is his Kinrade coil, and this is the picture that fascinated me since the beginning. It's such a strange-looking device. And there's basically a self-induction coil here, a type of induction coil. This particular coil was designed for direct currents. There's a motor interrupter, which chopped up the DC into AC. Then there's a huge spark gap. What's unusual about this spark gap is that it's over 6 inches in diameter. And it's water cooled. It has this kind of coffee pot looking thing on top that would keep it cool, and then 2 pancake coils. The condenser was housed in the base. This is one of Kinrade's photographs of discharges. It's just incredible. It's one of the, as Monell put it, it would have astonished Faraday beyond words to have seen this. This is some early photos of Kinrade coils being used to generate X-rays. At the time, there weren't many options. This coil weighed about 35 pounds, and incidentally, I don't know of any of these complete coils that still exist, but I have bits and pieces of information on them. This apparatus weighed about 30 pounds. At the time, the only other option were static machines, and to have a good static machine meant having something that took up an entire room. Frank, my friend, can tell you later that he's just found one of them, and they have to dedicate an entire room of their house just to hold this thing. And otherwise, there were induction coils, which contained a 12-inch induction coil, a coil to make a 12-inch spark from batteries, contain over 40 miles of wire. It's a major investment. This coil here had just a few ounces of wire in the secondary and produced an even more powerful discharge. Here's the reproduction I did. You can see the sparking to the right, and the coils are housed here. I changed the spark gap a bit to something more practical, and the coils are actually housed inside of these glass lampshades, and they're insulated with beeswax and rosin, which is the same recipe Kinrade and Tesla used. But what's surprising is the height of this box is only 2 inches and contains all of the components, coils and everything. This is actually Kinrade's home. It's purple, which is a little different for a Victorian-era home. This is the entrance to the secret passageways. There was no electric lighting in the basement. I was basically using my digital camera's zoom, gave a little bit of light, and I could actually look around using that. And it was a little eerie to be underground, this home snooping around. Here's one of the glass plates, one of the first ones I had found. And incidentally, of 500 plates, most of them are damaged. Some of them, it ranges anywhere from 90% to 10%. But still, the fact that they exist, the fact that they're here is amazing. I don't know of any other person to have made that many photos of spark discharges, and that includes Tesla. It was just an incredible feat, and that's all that I recovered. Who knows how many discharges, photos this man made in his lifetime. This is actually, I'd stumbled across a box of beeswax and rosin, and as I was rummaging through the box, I found some of his original pancake coils, and those are the 8 earliest surviving Tesla coils. This lab was from 1895 to 1901, and I found the coils were wrapped up in newspaper clippings, and the newspaper was from 1897, which puts the coil exactly at the time when he began his early work. To the right, I should have mentioned, when I first read about Kinrade, it was in a book by a man named Frederick French Strong. And Strong was a pioneer in electrotherapeutics. He was inspired to try to use Tesla coils for medical use after experiencing Kinrade's laboratory. I'll tell you the complete story a bit later. Here's an induction coil, the remains of one, that actually powered the coil that Strong witnessed in Kinrade's lab. Here's in operation one of the coils. This is a 11-inch diameter pancake coil, 16 inches tall. This post in the middle is around 18 inches tall, 4 inches diameter, completely filled with beeswax and rosin. There's a type of discharge. This was just the testing phase of the coil. All of the coils electrically function, which is incredible considering the state they were in. They were virtually underground, buried in dirt, leaves, mildew, you name it. Strong had witnessed Kinrade's laboratory, and in 1897, Kinrade was working with that induction coil in his earliest form of pancakes, and he had them insulated in oil, and it's been said that he produced the most powerful X-rays at that time period using Tesla coils or his flat spiral coils. I certainly believe it after seeing some of the photos of the discharges he made with his coils. It's just phenomenal. I've tried to reproduce the same photos, and even with the best coils of my collection, I can just barely reproduce what he was doing. And until I can actually make the glass plate negatives, which is the next step, because the glass plates respond a little bit different than modern film. I can get a better clue. But Strong had got the idea of building his own Tesla coil after visiting Kinraid's lab. And he had a blind patient that he was treating with a Geisler tube. And he was basically noticed that the blind patient could see slight flashes whenever the Geisler tube was flashing in front of her eyes. And nothing ever happened with the experiment, but she had remarked that she had a terrible headache and that she would get a series of migraines, and that the migraines would disappear after Strong's treatments. And Strong attributed it to not the Geisler tube, as he used different types, but as to the actual coil operating the tube that helped her headaches. From that point, he developed what's commonly known as the glass electrode for the violet ray machines. He was the inventor. And he was essentially the father of electrotherapeutics as far as high-frequency currents are concerned. This incredibly ornate apparatus was his Hercules coil. And it's, you can see a rotary spark gap and some Geisler tubes on the side. It has an important feature on top, which is called air gap condenser terminals. And he had kind of a dummy electrode in series with the output of his coil. And by adjusting this condenser to the left, he could actually superimpose different frequencies on top of his higher frequencies. And so he was really the first person to experiment with multi-frequency currents, long before Rife and others did in the 30s. To the right, you see a smaller version of one of his machines. Kinraid later worked with a man, Howard Jackson, to develop therapeutic currents with his style of pancake coil. And here you see a Jackson coil and the reproduction of one of the discharges from it. This was actually the instruction manual that came with one, had this beautiful fern effect produced by the coil on film. But you can see that there's hardly any sparks. It's mainly the ionization. And it's very, very gentle discharge, but very powerful. It's still several hundred watts of electricity being applied directly to the human body. And the fact that you don't get seared and cauterized by it's a miracle, but it creates an enormous amount of ozone, and it was an interesting approach to electrotherapy. Other companies began to see what Kinraid was doing and began to produce high-frequency X-ray coils. To the left, there's one by Sealy called the Vulcan coil. It's one of the most beautiful coils I've ever seen. Produces incredible discharge. To the right's a Victor, and you can see the type of coils that are inside. They're not your average Tesla coil. They're more like the one seen earlier in one of his patents. It's a multi-layered flat spiral, and extremely efficient. Only around 50 watts of input power, it produces a full 8-inch spark across the terminals. Here you can see some of the different company making beeswax-filled coils. This is what I'd call the Tesla coil of the future. Knowing the efficiencies of these coils, by refining the way you produce the currents, namely using tungsten spark gaps and mica capacitors, you can get incredible discharges. And this device here is only slightly larger than the previous reproduction I showed. It's housed in just a wooden box, and the discharges produce such intense heat that you can actually feel the heat several feet away of the spark. And it's slightly dangerous. I mean, you wouldn't want to conduct it to your skin. You'd be seared instantly. But it shows the efficiency of a 1 kilowatt Tesla coil. And it's kind of a different aspect. It's not looking at spark lengths and how much the coil can spark, but rather the quality and quantity of the sparks it produces. Oops. I think I'm going the wrong way around. By then, after Jackson and Kinraid developed in Strong therapeutic currents, by the 20s, a lot of quacks started to adopt the currents, but in the beginning, it was all legitimate. And here you see some of the early treatments with a Whedon resonator, which we're going to demonstrate later, And here's a simple vacuum tube treatment. Those tubes having been invented by Strong. At the top, you see actual diathermy of the eye with the Tesla currents. It's a bit brutal, but it was authentic use of high-frequency currents. The market became flooded with portable apparatus. These were mainly for therapeutic and also for surgical use. At the time, Tesla coils were one of the most humane devices to use for surgery because the cutting of tissues and coagulation of the tissues was with very little bleeding, and in the cases of removing cancerous cysts, it meant that you weren't reinfecting other parts of the body. The only problem was the lack of good anesthetics at that time. By the 20s, many home brew devices were built. By 1925, there were over 36 manufacturers of violet ray machines, and some of them made anywhere from 1 to 12 different models. And these machines were made into the tens of thousands by each manufacturer. At one time, it's probably safe to say there are hundreds of thousands of Tesla coils being manufactured, and they were probably more common than toasters. These devices, they started off as legitimate devices to treat various skin conditions and certain types of pain, and for fulguration, which is a light form of cautery. By the 20s, manufacturers, in order to sell more machines, put a lot of outrageous claims with the devices, and eventually they were taken off the market for the false claims. They were made to some extent to the 30s and 40s, and they became useful for the neon sign industry. Still uses them today to test tubing. And they've been reintroduced recently by estheticians for treating original skin conditions that the early units were made for. So they're still around 100 years later. You can buy very similar machines in both the US and in Europe. With the machines, you see some of the glass electrodes. They made them for each and every body part, and some you wouldn't imagine. The thought of treating yourself for hemorrhoids with a 50,000 volt electrode is a bit scary. Probably not many volunteers for that one. And if you've ever seen a broken hemorrhoid electrode, or worse yet, a broken urethral electrode, it just sends shivers up your spine wondering the history of it. But legitimately, they had some use. And actually, to the right here, you see dental electrodes. One of the least published topics is high-frequency currents in dentistry, and was actually very legitimate. Here you see me and one of the devices. Some of the excerpts from some of the manufacturers. You can see a wide variety of different types of machines. And they were sold in 2-piece units, 1-piece units, and they were a neat design for Tesla coil. And what's interesting, they could be run off of AC or DC. They didn't have transformers. They had a self-induction coil, condenser and interrupter, kind of like the original reproductions Tesla was doing, or the reproduction I did, Tesla did in the 1890s. It was a very common and very efficient apparatus. They only used about 20 watts and produced a decent 1-inch spark. And they have a lot of applications outside of, the only limits are your imagination, really. I knew a guy that used to use them as a stud finder for his walls. When he was hanging pictures, he would just touch them to the wall until it started arcing. Here's some of the examples of how many of the machines were made. I mean, it's easy. If you start collecting them, you'll end up with hundreds before you know it. They just litter the house. And they always scare the guests, and they amuse everyone. I mean, they're just curious. My cat's really fond of them. And it's one of the few devices that my wife actually likes. She doesn't, it's not as noisy and loud and intimidating as some of the larger machines. You can see some of the early ads to the machines. Stop that pain, thousands successfully used. And by the 20s, they were advertised as cure-alls, but once they started closing the manufacturers down, then they started to sell them as beauty aids. And by the end of the 30s, then they started reintroducing some of the kind of bogus claims. To give you an example, on the next page, you can see that they cure abscesses, baldness, blackheads, bruises, bunions, insomnia, obesity, pyorrhea, infantile paralysis. I mean, they're getting desperate here by the claims in some of the books. But for basic neuralgia, yep, that's legitimate. And for certain types of abscesses and for goiters, good luck. You're not going to kill anything with a tiny violet ray. The brutal use, but the authentic use of Tesla coils was for surgical diathermy. Here you can see some rather graphic images of people with cancer where it was removed with Tesla coils. And it's something not often seen and never mentioned by electrotherapeutic people today, but it was, by far, it was accepted worldwide. The devices manufactured for this were never banned. They were modernized a bit over the years, and they still use similar techniques today. And we'll be demonstrating one of these coils also.
Did the techniques help or hurt the condition?
They were used to remove the actual cysts from the condition, and in nearly all cases they helped. It wasn't a treatment sort of device. It was physically removing the problem. And in the case of cysts, external cysts, here internal cysts more so, you could remove a cyst without excessive bleeding. And that's what the important issue was, because the only other option was a scalpel. And when you're physically cutting away at something and the patient's bleeding, the cancerous cells could easily spread somewhere else and reinfect another part of the body. Here you see one of the discharges from a Fisher diathermy machine. It's not very friendly. It's not something you want to reach your finger down and see what it feels like. Or you might not end up with a finger when you take it back. But very elaborate, beautiful machines. They were designed like tanks. They're not a type of machine that you see that doesn't work 100 years later. I mean, they're all working beautifully. And they were designed, some of them, to operate 24/7, basically. So each component was pristine. It was made to the highest efficiency and to be able to withstand continuous use. Even the best of modern Tesla coils, you normally don't see ones that can operate continuously. Something burns up, something overheats, something goes wrong. In these coils, it isn't the case.
Back up one slide, please.
Sure. Whoop.
Now, at the top right, is that a before and after on the same lady?
Yes, that's the same person.
So,
And I don't remember the exact time frame here. I mean, but
so it like healed.
there was surely a lot of scarring, and this was, I don't know what the time elapse was, but probably months after. But the size of this.
Right, that was lupus on that particular picture too, which was a horrible disease, and still a horrible disease.
Oh, thank you, Frank. Lupus.
Is there any reasoning to believe that it would have slowly gone away by itself without any treatment? Or is it fairly certain that the treatment did cause the clearing up?
As far as lupus, and thanks again for that, Frank, I know that, what's a Danishman? Finzen used arc lights to treat lupus. And a lot of it, I think, had to do with the ultraviolet energy and the sparks generated. Finzen was a pioneer with carbon arc lights, and he had created some enormous arc lights to treat skin conditions. I've seen some of the conditions, and I'm no expert on lupus, but I know it's a very intense disease, and that I can't think of the best words, but it's you disintegrate rapidly with it as far as your conditions.
Ladies and gentlemen, we're going to ask that if you'd like to pose a question to the moderator or to the speaker, please raise your hand so that those that will be viewing this by benefit of the video, that your questions and comments will be on it. So as the speaker recognizes you, points you, raise your hand, we'll pass you a mic, okay?
Here you can see on beef, and this looks ridiculous, but some of the early manuals actually recommend testing your machines on beef before you go to patients. You could have drastic effects if not. But you can see it's intense, and this is slow motion right here. These discharges will instantly cook a piece of beef, so you can imagine what it does to a person. You can see the coagulation, bipolar coagulation to the right. It smells horribly. My wife was about ready to kill me when she walked downstairs and smelled this horrible smell in the house. But I'm fortunate to have someone that puts up with experiments like this on a continuous basis. To the top, you can see actual coagulation of tissue. It's called an Eberhardt localizer, and the meaning was if there was a cyst, you could place this around the cyst and use it as an indifferent electrode and relatively control the area you're cooking. Kind of some horrible pictures of bacon being cooked, but I didn't have much in the house at the time. You can see the elaborate spark gap of this Fisher diathermy machine. It's a tungsten faced copper. It's just an incredible spark gap. And as we'll see later with one of these machines, we're not talking about milliamps of current here. This is 1, 2, 3, 4 amps of high frequency current. The coils are operated by low voltage transformers, normally no more than 1,000 or 2,000 volts, and which means 1,000 or 2,000 volts at maybe 1,000 or 2,000 or more milliamps of current. It's much different than a neon transformer operating a Tesla coil. Back to me and my Kinrade projects. Here are some of the actual electric discharge photos recovered from Kinrade's lab. These originals were glass plate negatives, and I have a few I'll show you in a while. It's just incredible the different types of effects. The only experiments I've seen along these lines were done by a man, von Hippel, MIT in the 30s. But Kinrade was doing the same thing, and von Hippel had some elaborate apparatus, vacuum chambers, and Kinrade was doing it all with just Tesla coils in normal atmospheres. Here's some incredible positive discharges, negative discharges, and just some of the incredibly strange but interesting effects he was getting on film. The only way Kinrade's really been known is that he had received Keely's motor after he died. He was close friends with Keely, and he kind of distanced his friendship a bit because Keely was known as one of the most brilliant designers of different apparatus, but he was also a bit of a fraud. And Kinrade was left with his motor. This was one of the only, or some of the only photographic plates I have of those that I recovered, where it's actually of the motor that Keely's wife left to Kinrade. Where the motor is, no one knows. More than likely it disappeared from the house during the 20s sometime. Kinrade died in 27. But you can see partially here is the same motor disassembled. You can also see a table that it was sitting on and a compressed air line running down from the wall. And we can't really tell on the slide here, but the photo actually shows the wall was chiseled away. And as the story goes, Keely would invite investors to his home, show them a perpetual moving motor, and there was apparently a 30-ton air cylinder in the basement that was silently charged to keep the motor running. In any case, I think it's a fascinating motor, as with most of Keely's inventions. I'm not going to argue on the authenticity of them, but they're certainly interesting, if nothing else. And I'm working now with the family of Kinrade. He kept a diary. He was close friends with Keely. He separated himself, his business relationships with him, but he had kept a good diary of some of his inventions and newspaper clippings at the time. And one of these days we'll be able to publish what actually happened from the point that Keely died onward.
You say a lot of these photographic plates are made of glass?
Yes, they're all glass plate negatives.
I'm a little new on the scene in that respect. So in the older days, when people photograph something, it was onto a glass plate?
I can show you one here. Let's see.
I remember hearing about that in the old days, but I just never tuned into it. And
I'll show you two versions, actually. One will be with a white background so you can see what it is. The emulsion was actually on glass plates.
so it's,
And it's basically like film today, only instead of on plastic, it's on glass. The actual response is completely
so
different.
the picture's embedded in the glass
It's on one face of the
on
glass.
one surface.
Right.
Yes.
And if I can,
Okay.
the lighting's going to be difficult, but there's actually spark discharges all along this.
Thank you.
I don't know what year paper films come along, but they were basically the standard in the 1890s. And incidentally, all of the images at the Tesla Museum in Beograd, all of their archives are the same. It's glass plate negatives, and even the Colorado Springs photos, all of that were on glass originally. I've done some reproductions of these effects on modern film, and you can see the response is tremendous. You can capture on film what you can't really detect with the eye because it's going too fast or it's just minute amount of light. To the left is a charged sphere of metal and the discharge just traveling outward. You can see some of the ionization there.
Is there any reason to believe those are time exposures?
No, these were made, as far as Kinraid's, the early glass plate negatives were often exposed minutes on edge. For X-ray photos, for example, I've heard some insane things. That book Frank here found, he mentioned, what was it, a half-hour exposure? Imagine sitting under an X-ray tube for that long. It's just brutal, but I think average photographs may have taken 3 to 5 minutes.
So some of these probably were time exposures.
They were, but these photos are mine. They weren't time exposures. The earlier ones.
These are your own photos.
Yeah, these
Yes.
here. But the difference is there were time exposures, but the film took so much longer to expose. I'm no photographer, but it's something, what was it, half ISO, Frank? Which is half speed, or half ISO compared to today. There's 400, 600.
Oh, okay.
So they necessarily took several minutes just to show anything. Oh, wrong way around again. As far as modern Tesla coils, when I first started off, I built the typical coil that we all know of. Afterwards, though, the more turn-of-the-century coils I collected, I realized that most early Tesla coils weren't this form. And I was more curious in what the earlier forms looked like. But one of the advantages I found in making the modern style Tesla coil was that if you thread the coil forms, you could actually space wind the coils, and that fewer turns of wire often gave much better results. And also, it got rid of a lot of problems with winding the coils and having overlapping windings or unevenly spaced. If you simply take the coil forms on a lathe and turn threads in them, you can turn the lathe in reverse and just lie the wire right in the grooves. And you have perfect coils every time that way. And also, having the groove, you can easily shellac them because it just goes right into the grooves. And it's a good method if you have a lathe at your disposal. The second thing I found, almost universally, early Tesla coils used tungsten. And today, it just boggles my mind to see people using copper and all sorts of cheap things from the hardware store to make their coils. Tungsten makes a world of difference. In the case of the early coils, it's the only reason that they could be operated continuously. For me, it's the only way to go. And in my own, if anything else, I have coils 100 years old using tungsten spark gaps, and the spark gaps still work fine. So I think I encourage everyone to try to use tungsten if they're building a coil. There's really no second best in that case. you can see how elaborate some of the early coils had the copper heat sinks attached to the tungsten to keep it cool, to keep the gap quenched. It's an interesting design. It can be found anywhere, tungsten welding rods. They make great spark gaps for neon sign transformers. And if you go to a welding supply, you can even find little collets and holders that the welding torches use. And so it's easy to make some really nice spark gaps just with off-the-shelf items. The next thing I noticed, like the 1890s coils, kicking coils. It's not a transformer, it's just a single turn. In this case, there's two coils, but they're hooked in parallel, so they act as one. It's just a single turn or single coil of wire. And by breaking the current in this wire, it generates a high voltage pulse of back voltage that you can use to charge a condenser and discharge through a coil. This small coil here uses about 100 watts and produces a beautiful, with the pancake coil here, produces a nice 4-inch discharge. It's a different approach. You don't have a spark gap, instead you have an interrupter. And we'll show you some examples in a while of one of these operating. But it's a different approach. You don't need the transformer. You can work with much lower voltages. The capacitor only needs to be 1,000 volts or so. So they're much less expensive in the end. And there we go. The next improvement was the pancake coils. I'd encourage anyone to get away from the helix coils and to try something different. These flat spirals are incredible. The discharges, there's virtually no comparison between a normal helical coil. The current is just incredible. You can see the difference in the photo here. This was about a half-second exposure with two pancake coils, 9 inches in diameter and 1.5 inches tall. You do have to embed them with some type of resin. I use beeswax and rosin. It's the earliest formula and one of the best. There's epoxies and different things today, but they're so hard to work with. You can melt wax, get it a liquid, and just pour it around the coil so easily and let it cool. It's about the only way to go. And again, there's coils 100 years old that are still operating using this formula. And these are basically flat spirals. Each coil has about 300 turns of wire in the secondary, and the primary is just 1.5 turns of thick copper wire. Here's kind of a dissected turn-of-the-century pancake. You can see the windings. Paper was often used as interleaves to keep the windings from having crossovers when you're winding them. It's important to keep everything in line, or else if one of the turns slips down towards the middle, they'll short circuit when they're operating. You can see here, basically they're normally wound on Bakelite posts or hard rubber posts, and they just spiral around in layers. And the layers in these coils are only about 1/4 inch wide. The paper is much wider just to insulate it and to hold the wax and rosin in place. There are several windings in this coil, but it's actually one of the electrotherapeutic coils. The windings have different medical functions, but it's basically primary and secondary, just like a normal Tesla coil. Next is pancake magnifier, and I've just learned that someone else is doing this, which is good. It's basically a large pancake coil for the primary and secondary, and the tertiary or extra coil is a normal helix. And this system here uses less than 1 kilowatt and produces 4 to 5 foot sparks, but not your normal Tesla coil sparks. They're, again, very much hotter than what you normally see. It's an interesting arrangement. The 18-inch pancake coil alone gives beautiful discharges. From this, you can get easily 18 to 20 inch discharges from that. And it's only about the size of 18 inches square by 2 inches tall. So it's fairly compact. The flaming arc coils are something different. They're a basic pancake form, but there are many layers. And the layers are wider. It's a strange arrangement. In the center of the coil, you turn maybe 4 turns per layer, and as you move outward, you slowly increase that to 6 turns, 8 turns, 10 turns. And in this coil, it ends at about 32 turns per inch, and by the last layers. There's, I believe, if I remember, 24 layers of wire in this coil, and that's the one that was producing the incredible hot discharges. Next, conical coils, which are getting more common. Here's an early electrotherapeutic version from one of the surgical machines. Kinraid developed something interesting. He took a pancake coil and inverted it in such a way that it formed a cone. So it's many layers in a conical form. It's an interesting type of coil to experiment with. It's very efficient, and you can produce higher voltages than what you can in a pancake coil, but higher current than what you can in a helix coil. Just a few comments about Tesla in general. I've read a lot over the years, but I mainly try to focus on what Tesla himself wrote. And he's often painted as this eccentric character, kind of a science fiction character, and somewhat of an alien. I prefer to think differently. I think of Tesla more so as a Serb, and I think he also always considered himself a Serb first and an inventor second. The Serbian people are very interesting. They're not so eccentric. It's just a different type of culture. And I imagine Tesla more than anything with a smile and a great laugh. And I don't think at all that he's so much of a recluse and unfriendly or mysterious character. I think he was probably a typical Slav that's very easy to get along with, and having spoke with his grandnephew, I think he would share that view, that he's very human. And I've had the privilege of seeing some of his letters that he wrote from the Tesla Memorial Society. They published a few here and there, and it's incredible. You see that he really is a human and was a very... he wasn't an alien. He was a brilliant inventor and very, very much a Serb and very much probably a very likable person. And here was the obituary I found. It's the last slide from the PowerPoint. This was used as a page mark in his 1893 lecture. So someone who had that book was definitely cared about who wrote the book, enough so to keep the announcement of his biography, which was a year later, by O'Neill. But it's an interesting obituary. It's on the website. It's one of the few, it's the best quality obituary I've seen because most of them are taken from microfiche from the early newspapers. So I encourage everyone to take a look at it.
Is that supposed to be his picture there?
Yes, that's a picture
In his older years?
in his older years. There's a book, Master of Lightning, I'd encourage everyone to get. There's more photos in that book of Tesla than any other you'll see. It's just a picture book. You open it up, put it on your coffee table, and there's hundreds of photos. And it's a book that will really hit you when you see the photos of Tesla in his older years. They're pictures that I wasn't expecting to see, and it's really kind of sends shivers when you see the condition he was in at the end of his life. But maybe we can go on to some of these devices. I'd like to introduce a special friend, Frank Jones. Frank drove all the way from Spirit Lake, Idaho, and brought some of these wonderful coils. He's one of the only people I can call on the phone and ask silly questions like, Frank, do you have a screw to a Fisher spark gap? And Frank will ask, which version, the early 20s or the late 20s? Oh, the early 20s. Yeah, I have 6 of them. And in turn, I'll send you a few pieces of mica in return. And it's great to know that someone else is obsessed with these early technologies. Here's an example of a Victor. This was probably 1905 or so, I'm not sure.
1905 to 1910.
And it's a clever little device. It doesn't have a transformer. It operates with the kicking coils. There's a kind of a vibrating coil that charges the condenser in the base, and there's a pancake coil on the top. It's a clever design. It's the only Victor I've seen of this design. And next to it's kind of a common device. This is one of the earliest violet rays made by a company, Fisher. It was kind of different in that instead of having a hand electrode, you could conduct the current to the glass electrodes which were inserted in here. And it produces about a 1-inch spark. It's a lot powerful than most of the home units, but this is one of the machines that was made before all of the quack claims came around. And it's a classic. The advertisement in the violet rays, one of the things you'll see in the 20s, the booklets say only used for 5 minutes, only used for 10 minutes. The book that came with this machine says, use it as long as you want, it'll outlive you. And sure enough, it sure did. Here's 2 examples of ones that work 100 years later without any problems.
Yeah, these machines aren't even the best of shape. They're water damaged, they've been mildewed. Chances are most of these were relegated to a basement. And this is what's left of the original power cord. And they still work. Not many modern inventions can do that. With Tesla inventing his coils, this is a Whedon coil, which most people mistakenly call a Tesla coil. Because typical Tesla coil was never, the secondaries were never connected to the primary. Whedon did that. Tesla did not. Tesla had a secondary coil with 2 ends, and the primary was not electrically connected to it. And most people mistakenly call this a Tesla coil. This machine, which we will demonstrate later, is a medical therapeutic, as Jeff was mentioning, with electrosurgery, electrocautery. Before, to excise a tumor and do surgery, they did it 1 of 2 ways. Basically, a heated knife and slice it. Later, they had a platinum tip, and they would heat the tip with a battery and burn the tissue. Well, again, there was a lot of bleeding, a lot of possibility of disease transfer. When they got to a Tesla coil is RF. It's no longer in the realm of DC or AC, it's in the realm of RF. Sometimes 30 kilocycles, 100 kilocycles, whatever. The RF energy was really neat. I'm sure many of you have touched the Tesla coil and you have those wonderful white little scars on the end of your finger that hurt like a bugger. Touch this one, I guarantee you will wish you had the little white ones. But the Tesla energies, for some reason, it would cauterize the tissue, it would immediately stop bleeding. It would also desiccate the tissue on both sides a little bit, very minimal scarring. That picture of that woman Jeff's got the book and I've got the book. The photograph is amazing of what they removed with that there's very little actual scarring. It's white, but it was smooth. It's a different form of energy for physical treatment. And by using Tesla, Jeff, like I said, he was going to bring one. It was simple. It was single wire, and they just had a curved blade, whether it was looked like a knife, whether it looked like a disc, whether it looked like a ball.
Actually similar to this in some respects.
And with those, they could slice them. Today, folks, they still have these machines in hospitals. It's called a Bovie machine. And Bovie took this same Tesla principle and made it compact. The military uses them, and they're still used as a form of RF energy for treatment of, not treatment, but electrosurgical applications because of the properties of the cutting. It can, especially in cancers, because cancer is notorious. You've got to excise so much tissue, and then they usually go beyond that amount of tissue just to make sure. With a Bovie machine or electrosurgical using RF energies, they can go basically to the perimeter of the tumor, localize it. The woman on the nose, you don't see it, with that tumor on her nose, they actually excised that. They didn't take half the nose, they didn't take half the cheek. There's something to be said about this stuff. It's still unknown. When this other gentleman was asking about film, the glass plate negatives basically started about 1880, I think. There's daguerreotype, and then there was an ambrotype. Then the glass plate negatives till Kodak developed the flexible celluloid film just after the turn of the century. But until then, these were, most of these were called a gelatin negative, that they actually coated the film with gelatin, jello, and then on top of that, they would put a silver nitrate emulsion. And then the film would become light sensitive, and the silver nitrate emulsion, and coupled with the gelatin, would expose an image. The gelatin stuck the image to the glass. That's why, unfortunately, when water hit it, it would dissolve it. The ASA for the film buffs was 1/2 to 1, the speed of the film. And as Jeff said, and I've got many examples of X-ray exposures, 30 minutes was not uncommon to expose, required to expose this film. There's one where the guy has his hand on the plate on a hand like this, and it's 10 minutes to expose the film. The difference between X-rays then and X-rays now is not the equipment. A cold cathode, what I call a cold cathode X-ray tube or a modern X-ray tube, it's not the tube, it was the film. The speed of the film is taking exposures from minutes, or sometimes even almost an hour, down to tenths of a minute.
I've done even with some of these tubes on modern film. It's amazing. It'll expose within seconds at times. The X-rays are powerful enough from these early
You guys
devices.
don't know me. I do know John Bendini. I live near him, and I've worked with John some on his Rife stuff, by the way. I've always been interested in the electromedical. Anything that throws sparks is something that interests me, and Tesla was one that really interested me because of the energy you can get from this coil that, okay, they're safe. I mean, I can touch it, I can get burned, but I cannot touch a neon sign transformer or a pole peg transformer and survive. I can touch these and survive. However, I can't touch that and survive, trust me. And as a result, I have been interested in these forever. I've restored these coils, I've picked them up. This coil was mine. It belongs to a dear friend. I don't know if he's here. He's here. And he was gracious enough to loan it to me. But I got this coil when I was 18 years old and had to completely restore it. It was flooded in the basement. There was that much water. Part of the spark gap had fallen apart. Some of the hard rubber in here disintegrated. I rewound this coil for him. I rewound the top, rebuilt the machine, and it's still running. It's neat in that it's electrotherapy, but it also demonstrates many interesting Tesla principles. There's 2 coils in here. The one they call a Whedon, and this, where'd the ball go? That ball is called a Tesla. And I'll let Jeff talk to you about it, but this is a pancake coil. It's a pancake coil of 6 turns. Not many turns, 6 turns. When you folks see the discharge from this, you will be absolutely amazed. We've drawn a picture of the coil there, that the primary high voltage comes in at 2 3/4 turns. So basically, this is a 1-to-1 transformer. You've got 3 turns, say, on the primary, it's excited. The other 3 turns where the high voltage comes out on the secondary. 1-to-1. Now, 1-to-1 transformer, you say, it's not going to get much output. But what they discovered with this and what Tesla discovered is resonance. He got it down pat, and if you make these things perfect in resonance, they work. This secondary on this coil is 114 turns. When you see the discharge, you can't believe it. 114 turns will give this discharge. Again, it's resonance. And you only see a discharge on the coil right here at the top. If they're designed right, as Tesla said, you do not need any insulation on the wire. All the turns are in resonance with each other. There was no arcing or discharges anywhere on his coils, only at the ends.
And another interesting note, and I've spoke hours on end with Frank on this subject, the secrets of Tesla coils is resonance and current, not voltage. One of the biggest mistakes is, not a mistake, but it's just a way of doing things. All of the early coils that I own, and Frank as well, were powered by low voltage transformers, no more than 1,000 or 2,000 volts normally. And at 1,000 or 2,000 volts, we're talking not 30 or 60 milliamps, but...
We got the mic for him? He's got a question there.
Oh, yeah. There you go.
Thank you. What,
Well,
What power were you going to say, not 30 or 60 million?
we're turning it on now.
what,
Yeah, finish your thought. Not 30 or 60 million?
Yeah, the transformer, for example, in most early X-ray units, was 1,000 or 2,000 volts at 2 or 3 amps current, 2 or 3,000 milliamps, not 30 or 60 from a neon transformer. And the turns ratios, as you see here, it's almost 1-to-1. So how can you expect to get any spark out of this coil if your voltage, you're only starting off with 1,000 volts. Theoretically, if you use the lump sum theories, you're going to get 1,000 volts out of it. Instead, you get, who knows, 100,000 out of this one
100,000
probably.
roughly, yeah.
And it's all due to resonance. And one of the things I've been developing are adjustable condensers. And I'm not going to get into it this lecture because I'm in the patent process, but the adjustment of the condenser will find resonance in any coil. I have a condenser now that's adjustable from 0.001 microfarads to 1 microfarad in 0.001 increments. With this condenser, you can virtually hook it up to any Tesla coil and find resonance. And once you do, it's incredible to see the difference that just a few microfarads can do to a circuit. In the case of pancake coils, you can't adjust the taps on the primary. You have to have the right condenser because the primary is embedded in beeswax and rosin. You're not going to do much to it. But
actually, I have several questions, but in that like 1-to-1 type ratio, what drives the primary? What voltage and what frequency and so forth?
10 kV transformer.
A 10 kilovolt transformer
Yes,
at
it's 10,000
60
volts.
cycles?
At 60 cycles, it's charging a cap. I don't know the value of the cap on this unit.
We've drawn what I call the tank circuit. It's a high voltage transformer, parallel spark gap, which many Tesla coils use, series condensers to the output circuit. Again, this is one of the most common Tesla circuits you'll ever see. This particular machine uses that there and physically swaps those two windings to this circuit there, and there's one other circuit inside it. There's actually 3 different oscillator transformers in this particular unit. One's called a D'Arsonval solenoid, which was always a low frequency, low voltage, but high current coil. The Tesla coil in here and the Whedon coil on top.
Okay, so 10 kilovolts at 60 cycles. Approximately what was the input current? You probably have said it, but...
On this, the transformer goes up to
The transformer is rated
10
at 10 amps max input.
10 amps max. But I'm trying to estimate the power, the kilowatts or something that went into the device.
Unloaded, there's a key to there, unloaded. This thing probably idles at the sparks you'll see at probably no more than 2 amperes input current.
It's 2 amperes at 10 kilovolts?
2 amperes at 110 volts, so that'd
At
be 2
110.
kilowatts, say roughly. Or excuse me, 200 watts. 200 watts input, unloaded.
Okay.
The key to these, obviously, if you hooked a patient or something to draw the energy, the input power will start to increase to maintain the output. But we're running this in basically an unloaded mode.
Yes.
The input current off the AC line is only about 2 to 3 amperes. Now, if you load it, I've blown the fuses in here, and there's 20 amp fuses in here. I've popped the circuit breakers in the house. I've done all sorts of wonderful things.
The transformer's about a square foot, actually, in the base of that.
Yeah.
It's massive.
Okay, could you say, to the best of your knowledge, where each of these different devices came from? Were they found in the basement of a home, or, and any of them directly Tesla's product, or whatever?
These came out of basements and homes back east and down south, and hence the horrible condition. This, I can exactly tell you where it came from. I have an electrical engineering degree. I used to work at the university. I worked repairing analytical equipment, MRIs, this and that. This was down in the basement of the EE department. It was a 1910 laboratory. And I wanted this machine for years, and I had to wait till all the professors died, or I had to kill some of them to get it, because they wouldn't get rid of it. They were always going to give it to a museum. Well, I know this museum didn't want it. Well, like I said, this was in this much water. The basement flooded one year, and I had enough. So I made a midnight raid. I didn't have a key to the basement, but I noticed that the difference between the key I had for my office was one little tip. So I soldered a tip on there, filed it down, broke into the basement, and I took this because it was getting destroyed. But I knew an old doctor that worked at the university in the student health services. These machines were donated to the university. They were used in the student health. This doctor actually used this. These currents were diathermy, so they did it for heating, physical effects, surgery, and when they became out of favor, and this machine, folks, was built in 1927. This is not a turn of the century. This is 1927. The only reason they obsoleted this machine was because it wasn't controlled on frequency. It's a broadband generator. So as they started going to the shortwave diathermy, which was the next step, they were still a free-running oscillator, but they were kind of 12 megahertz or 27 megahertz. Then after the war, they said, we've got to be crystal controlled because everybody started using radio. Before that, everybody just used AM radio mainly. But this was used in the medical profession. It came from Bozeman, Montana. Who bought the machine originally? I don't know. I do not know who bought it.
Do any modern hospitals use descendants of that machine?
Modern hospitals today, yes. There's actually two descendants that they still use. There's still shortwave diathermy used today. A lot of people use ultrasound for heating tissues, but shortwave diathermy is still used in a lot of physical therapy. The other machine that's used, anybody here got a back problem besides me? Anybody use a TENS machine? TENS, transneural stimulation? Well, a TENS machine is a modern version, size of a cigarette pack, is what they call a Faraday coil. It's just a DC pulse that stimulates the nerve to the point where the nerve shuts down. It uses its chemicals up to send pain, so it's a pain blocker. 100 to 150 years ago, they were called Faraday batteries. They were an induction coil modified, wonderful to shock you with and have fun with the neighbors. They thought they cured diseases because the symptoms went away. Symptoms went away because it blocked the pain. That, 150 years ago, I have some coils that were built during the Civil War, 1860s. Nowadays, they use the same type of energy. They realize it's a pain blocker. It doesn't cure, but it's a pain blocker. Diathermy is still the only way to get deep intramuscular heat. Ultrasound will not penetrate. It's still sound waves. It diminishes as it goes in. Diathermy still works, and they use a modern form of diathermy. The frequencies are different. This is around 100 kilohertz. The diathermies today are 27 megahertz. And they also use microwave diathermies. I have a microtherm where they actually have a microwave antenna, and they run at 2 gigahertz. It's a freestanding microwave oven.
Yeah. Okay, I have one last comment that, probably not even 1 out of 1 million people on this earth are aware of this type of technology and that it existed then. And what I've seen here, I never imagined it existed myself, and it's such a great tribute to Tesla, and it's a tribute to you guys who have dug this stuff out and preserved it for posterity. You know, it's unimaginable almost, and I think you guys have done such a wonderful job preserving and presenting this stuff.
Thank you. Let's fire up the Hogan.
All right, the best for last. And also, after the lecture's over, you're welcome to come down. I can open the cabinet up here and you can see how this machine is plumbed. I say plumbed because there's 1/4-inch copper tubing as a wiring in here. Which mode do you want to go first?
What voltage is being applied here?
On which part? 110 volt in.
Let's start with a Whedon. Why not?
Okay.
It's a low power.
Yeah, it's at low power. Okay, Whedon coil first. This is a low frequency coil. That's low frequency, low output.
Low power.
Low power.
Theoretically. Whoop.
Notice when I'm drawing the energy, she's losing the energy.
Frank, can you keep your microphone away from the coil? or while you're working, just turn away from it so we still want to hear you.
You notice? Now,
Show the Tesla.
the second output, totally different frequency. I haven't got a clue what this frequency is as Tesla. This is this 6-turn coil.
This is pure resonance.
It's this ball right here. And we'll start out.
Okay, ladies and gentlemen, I know we're starting to run tight on time. The presenters have about 2 more minutes. However, there is an evening social, and those that want to remain for a few minutes, as long as the presenters choose to, we'll allow them to go ahead and continue to do displays. There's one rule, the 36-inch rule. You cannot come within 36 inches without their hand being involved with you and their hand giving you permission, okay? But otherwise, if as Frank and Jeff see fit, we'll continue the experiments and the demonstration. This display will be removed this evening, so if you'd like to examine any of Jeff's or Frank's displays closer, now's the time. For those of you who wanted to or had to go to other appointments or go to the evening social, you're free to. You're done in about a minute, but we'll keep on with the experiments.
You can hear a spark gap running. You don't see anything. What do these controls do?
No, I mean, what are those controls?
Okay, this is just strictly basically an auto transformer to control the input voltage to increase power. This machine has a series of spark gaps. This is a spark gap regulator, just like I say, it's basically a Tesla coil. Yes, it does. It actually has a multiple set of plates. There's a group of stationary plates and a group of movable, and all the movable plates run in parallel against the stationary plates. Yeah, it's a multiple spark gap. You can,
The 10 series gap, I think.
How many coils, you had a third area and a fourth area, as well as the first and secondary, what kind of effect did you get from that?
As far as multiple primaries or taps?
Or multiple secondaries, yeah, in other words, a secondary and then a third area and a fourth area.
Well, actually, this coil here is tapped at different points.
Yeah.
Just to get lower voltages.
Okay, now you're seeing in a flue here. That's 1-to-1. Now what? Many people are asking about taps. This is the diathermy coil. There's a tap right here at, okay, the primary comes in basically at 0 to 3 turns. At 4.5, there's another tap. So this is That's resonance, 1 turn. Resonance versus non-resonance on a 1-to-1 ratio. This is what's neat about this, is it shows 2 different types of coils. Like I say, a very simple pancake and a Whedon, but not a lot of turns. Everybody thinks Tesla coils have to be miles long and miles wide and high voltage. They don't. Resonance.
So is there a capacitor in here?
Yes, there's an oil-filled capacitor. There's a capacitor in series with each side of the oscillator circuit. If you guys want to come up afterwards, there's actually the original schematic still.